Today we've got a big 50-inch Samsung. It's a PS50C98HD. Symptom is, like most Samsung plasmas, no picture, and what clicks on, there's no picture. On the left-hand side of the screen, we have some kind of occasional flashing pixels and looks like sparking. So we may have a shorted plasma panel, but a more common issue with the set, and the plasma panels are quite reliable themselves, a more common issue is the Y main. In particular, if we look closely at the Y main, you probably can't see it on the video, but anyway, that capacitor down there is bulging. Usually that fuse there blows, and this FET there shorts, and the buffer IC there fails. So it's a fairly catastrophic failure, but that's typical for you. Now on this chassis you've got to be very careful. You cannot run it with just one of these buffers disconnected if this is blown out, because what you will do is you'll then blow up that chip on that buffer, because that's fun. It addresses these sequentially, so it starts at the top, then goes to the next, and then the next, and so if there's a short and these aren't present, these won't be addressed, but then this one will be addressed and that will short and you'll burn a hole in that. If you look carefully at that, you see the white mark on it, whereas there isn't one there, so that IC there has blown itself to pieces. Very, very, very common issue. If you in fact look at the layout, so the topmost row is here, you follow the trace along there, you see it goes to there, and the part of the chip that's blown out is right at the edge there, so it's the first line of the screen that it's trying to address has failed on the IC, and it's consequently destroyed the IC. So, what we need to do is, ideally you should use an oscilloscope to check if the X main's good, and to test the Y main without the buffers connected. You cannot have a single buffer, you can't have one buffer connected, you've got to have both of them disconnected to do the test. But more than likely, what's happened is the Y main has killed the buffer. So I'll just plug it in, and we'll see another useful feature. Okay. Oh, plug that in too. Okay. Get the remote. Okay, it just clicks on. That's normal. This chassis, there isn't a short between. There is no short between VS and ground on this one. The VS is not shorted. So what we'll get is we get a green LED lit up on the Y main, which indicates the Y main is in protection mode and is faulty. The X main I don't think has such an LED, so we need to test the X main. I hooked up the X main to the scope, and we got a good waveform, so that's alright. Okay, so what I've done now is I've pulled the Y main out of the TV, and we're going to have a closer look at the problem. Problems start over here, where we have one bulging capacitor. It's a Samware, by the way. That's not at all unexpected. Samware are some of the worst capacitors in the world. That fuse is okay. That fuse is okay. I previously thought that might be blown, but actually it's fine. Down here we have these. I initially in the video previously declared these to be bad. Actually, these all test okay. What's failed on this one are these down here. So we've probably see it there. Let's see about this fancy autofocus. It doesn't seem to work, but anyway, you see the significant burning around there. Each of these is dead short. Well, actually some of them could have survived, but more than likely all four are dead short. That there is short. Other damage, there's a little resistor there, gate drive resistor, that's open. And there's a xenodiode there which is testing, I believe, shorted. So it's fairly catastrophic on this board. Oh, and it's then killed the buffer board. I'll just get the buffer. Find the right one. Take this one. Okay. Here's the buffer board, and it's got a hole in the IC there. and in fact that's glowing orange when the TV is on, so it's not doing too well, to be honest. I traced the fault. It's obviously the first addressed line, because if you look at how it's wired up, there the failure zone is right next to the first drive line on here. So these are shift registers, by the way. So the control board loads all zeros into them and shifts a 1 down the panel to scan the panel, and then loads all 1s into them. But basically inside you've got two switches. You've got a high switch and a low switch, and the switch can either go high, which means it connects this to one of the electrodes, or you can go low, which means it pulls the electrode low. What tends to happen on these TVs, they're a little naughty in the design. The switches are only rated for 170 or 200 volts or whatever VS is. What they tend to do is they need to apply the V setup ramp, which is about 400 volts peak. So they'll rely on the IC breaking over internally. Now you can do that as long as that breakover period, the total energy dissipated is less than what the chip can handle. And usually you have a heatsink on them to handle that, but anyway. What tends to happen is down here, this is one of the ramp FETs. This is the Y forward ramp, which means the positive ramp, YFR. The YFR FET can short, which means the it's got 400 volts relatively continuously until the little power supply on there goes to protect mode. And so this buffer IC can't take it, goes bang, because it's trying to send that into the panel. And you get a line short, and once the IC gets one transistor and it failed, it tends to cause rather catastrophic damage to the rest of the components, because it gets so hot the die can crack. These are the transistors. Now I'm not sure how they failed. Now it may be because they're also relying on the same idea. They can briefly withstand a 400 volt pulse, or it may simply be because when the buffer failed, it drew too much current from the sustaining period, which damaged them. Usually that would blow the fuse though, so I'm not entirely sure about what's caused it to fail. It may be an unrelated failure, it may be related to that capacitor failing, because the reason that FET in the first place, that little ramp FET failed, is because that capacitor bulged. That capacitor supplies the gate drive voltage, and it's local decoupling basically. You've got long wires going to the gate on the FET, long wires from the power supply supplying the gate voltage, about 15 volts, and these wires have a lot of inductance, and if you don't decouple that to a local ground, you get a lot of instability in that voltage, and it can get, when you try and draw that current from the sustain pulse, you get a little dip, no longer able to supply the voltage, so the gate of the MOSFET sees a lower voltage than it should, and this causes it to dissipate a lot more heat, and it runs very hot. This device here has also failed, so I'll discuss later in a second video how we're going to repair this, but basically it's going to involve about £30 worth of parts to fix it. If we just did a board swap, which is costly, it's going to be looking at about 150 quid, but if we do a component level repair, we can get it done for about £30 at most. So we'll do that before anything else. Samsung engineering, how we've missed you. Oh yes, and there's one thing I've mentioned in the video. That LED there lights up when it's in protection mode, which basically means it's detected a problem on the sustain board, which is nice I suppose, but it does go into protect mode, but it obviously wasn't quick enough to protect the buffers from failure. I don't know if they tested that.